In calculus, we talk about curves a lot, and you're going to get to find the area under a curve. So you might have something like this problem where you have to find the area under the curve. And it's quite difficult to do when you first start out. It's easy to take the area under a rectangle here. You know, the area is height times base. Well, we have some kind of A and B here. Okay, they're called the endpoints here. And then we have the K for the height, and that would be your area. The same with the trapezoid. But when you don't have a formula for something like this, so what we're going to do is we're going to approximate areas by partitioning areas under a curve. And the way we can do it is we can partition it in 2 subintervals, 4 subintervals, or more. All right? These U's here are called endpoints. So they're the units. So this is called the units by the left endpoints. And on this one, we're going to use the right endpoints, which would be like this. We'll take the area of the right endpoints. Okay? This is over the interval A to B. And, yeah, this is the area of A to B. And this length here would be F of B. And, I mean, the length here would be F of A. Okay, for something. So that's what we're going to do in this video is we're going to take an example, a simple example, and partition under the line y equals 2x. So here it is. We're going to approximate the area under the graph of f of x equals 2x. It's this line here, and I'm sorry if it's not proportional. This is definitely not proportional. So what I'm going to do, and I'm going to do this one we're partitioning between 0 and 1. So that's 0 and 1. That is like our A and B on the previous video. And what we want to do first is choose a U as a left endpoint. So our first unit, we're going to start here and here. And what I'm going to do is find the area. So we do, we're going to start with these 2 endpoints here. So we're going to take the area of each piece. So we have f of 0 times 1/2, because this unit here is 1/2. And this unit here is 1/2. You want them in equal intervals here. Okay? So this is like your length times your base, plus, then we're going to take f of 1, that's your length, this is f of 1 here, times your base. Okay, f of 0 is just 0, so we get f of 1. F of 1 is 2, so we get 2 times 1/2. No, it's actually 1. When I plug in 1, I get 2, so what am I getting? We're taking f of 1/2, sorry. So basically, we're taking f of 1/2, because this is 1/2 right here. This was for this part, and this one is for this part. So when you take f of 1/2, that equals 1, and 1 times 1/2 equals 1/2. So we would say the area under this line, if we approximate it, is 100. I mean, it's 1/2. All right? Now we're going to do the same one, but we're going to use the endpoints to the right. So I had the same thing, but I'm using these 2 as my endpoints for my formula. So basically what I'm going to say is the area equals f of 1/2, which is this length here, right here, times 1/2, which is the base from here to here, plus f of 1, this is f of 1 here, this part is f of 1, times 1/2, because each of these units here is 1/2, and you're talking about the base. So f of 1/2 is 1 times 1/2 plus f of 1 is 2 times 1/2. And what you get is 1/2 plus 1, which equals 3/2. So when we do it this way, our area ends up being 1.5. So it's the same function, but when we use the right endpoints to approximate the area, we got 1.5. Now we're going to use 4 intervals. So basically, in this case, we're using the right endpoints, which is, the left. So this one, 2, 3, and 4. So we still have the same graph, but we're partitioning it into 4 subintervals. The first one being f of 0 times 1/4, because all of these are 1/4. All right? The next one's going to be f of 1/4 times 1/4. Remember, this is your height times your base. Height times your base. Or you can say your y times your x. Plus f of 1/2, we're doing this one now, times 1/4, which is basically your 1/4 are here. That's 4 subintervals here. Okay, plus f, let me do it here, f of 3/4 times 1/4. All right? So when you plug everything in, you're going to get 0 times 1/4, that goes away. F of 1/4 is actually 1/2. So you get 1/2 times 1/4 plus 1 times 1/4 plus 3/2 times 1/4. And when you add all that together, that all equals 3/4. Okay? Basically, you're just plugging your f value into this. So that would be the area if we subdivided it into 4 subintervals. Again, here's our 4 subintervals. But we used our left endpoints. Okay? And we're going to do one more, and now we're using our right endpoints. So this would be this one. These are our right endpoints. And all that means is our intervals are still at 1/4. So we have 1, let me do it in red. 1, 2, 3, 4. But we have 4 endpoints. We need 4 endpoints, not 5. So you either can use the right or the left. And this one we're using the right. And we're taking f of 1/4 times 1/4. Because 1/4, all of these are going to be 1/4. Plus f of 1/2 times 1/4. Plus f of 3/4 times 1/4 plus f of 1 times 1/4. Okay, f of 1/4 is 1/2, so we have 1/2 times 1/4. F of 1/2 is 1 times 1/4. F of 3/4 is 3/2 times, this is plus here, plus 1/4. And this is going to be 2 times 1/4. And when you add all this together, you get 5/4, which equals 1.25. So basically, by taking the right endpoints here, our area ended up being 1.25. And that's approximating the area under this line, y equals 2x. Okay? And the actual area, if you look at the actual area, we had a triangle, because this is y equals 2x. So this is the 2, and this is the 1. And that's 1/2 base times height. And the actual area was 1. So if I look back here, none of my areas were exact. None of them were 1. So that's why it's called approximating the area under the graph. Okay, the next video I do is going to be the area problem, and I'm going to approximate the area under a curve.